Hello everyone, I am Cadet Liwa, a member of Group 5, and my group mates are Cadet Liaban, Cadet Mangkaw, Cadet Ofyanga, Cadet Pahaganas, and Cadet Merto. And today, we are going to report planning and execution of blind pilotage and anchorage. So, first things first, we have our intended learning outcomes. So our ILO for this report is to understand what blind pilotage and anchoring means, as well as its planning stage and execution stage. To comprehend the duties and responsibilities of the OOW, the master, and the pilot during blind pilotage and anchorage operations. And lastly, to know the symbols used, navigational records, and the team's obligations. So, let's talk about blind pilotage. Basically, this means that the navigation of the ship through restricted waters in low visibility with little or no recourse to the ship. So, means there is only small room for the ship to navigate. So, the principal non-visual aid to navigation that enables this to be done is high-definition warming surface radar, but all available non-visual aids are employed. The organization to achieve this is called the Blind Pilotage Organization, comprising a BP team or the Blind Pilotage Team, led by a BP officer or BPO or the Blind Pilotage Officer. So next, we have the assessment of risk involved in a blind pilotage passage. So although normally the accuracy of blind pilotage is such that a ship can be taken to an open anchorage and anchored within 50 yards of the desired place, the degrees of risk involved, particularly in restricted waters, must be carefully assessed. Congestion due to other shipping, the consequences of failure of radar and other vital aids once the ship has been committed to her passage, and the number of quality of fixing marks must be taken into account. So, in relation, we have here the parallel indexing. So, this type of navigation technique will serve as the key so that this blind pilotage will be avoided because it provides a real-time information so that you can keep track of the lateral position of the ship. So we have here, the key to blind pilotage is the principle of the parallel index. The running of a parallel index line provides a real-time information on the ship's lateral position relative to the planned track. So next, we have here the figure 1. So basically, it is the parallel index. So a line is drawn from the edge of a radar conspicuous object, parallel to the planned track. The perpendicular distance or the cross index range. The perpendicular distance or the cross index range from the object to the track is then measured. Then, the range strobe on the radar is then set to this range, and a solid chinograph line drawn on the display parallel to the planned course on a scale appropriate to the range in use. Positions 1, 2, and 3 on the chart or radar display show the ship on the track at various instances up to the time the island is abeam to starboard. Positions 4 and 5 show the ship off track to port. So next, we have radar clearing ranges. So figure 2 are similarly drawn at the maximum or minimum distances from the radar conspicuous objects to keep the ship clear of dangers. So these are drawn as broken lines. So as you can see here, we have the image of radar clearing ranges. So the center line is the planned track or the planned course, and also in the side part. So that's our parallel index line. And by the time the vessel will alter new course, so there is also new parallel index line for the new course. So that's it for my part. Thank you so much.
Liaban, and I am the next reporter for this group. So I'm here to discuss about the course alteration. Is where the wheel of overposition are calculated and plotted on the chart as for the visual plottage. A radar conspicuous mark is selected as close as possible to the wheel over position. A pet line is a broken line is then drawn through the wheel over position, parallel to the new course and the course index range. This wheel over range is plotted on the display as a pet line parallel to the new course. When the selected mark reaches this line, the wheel should be put over and the ship brought round to the new course, by which time the mark should be on the firm line, denoting the parallel index for the new course. So next slide. The responsibilities. The responsibilities for pilotage is clearly vested in the captain. In normal circumstances, the navigating officer is the pilot of the ship, although if he is not a navigation subspecialist, the duty of the pilotage develops on the captain, who may either perform it himself or at his discretion depute any officers of the ship's complement to do so. No matter what the blind pilotage organization may be, the subspecialist navigating officer, or the NO, is always the pilot of the ship, and thus he should be the blind pilotage officer, or the BPO. So next slide is the conduct of blind pilotage. The navigating officer, or the NO, remain on the bridge in poor visibility and conduct the blind pilotage from there. So what is a blind safety officer, or the VSO? In the operation room, where he can monitor the blind pilotage and back to the navigating officer on the bridge, the VSO will need to be in touch with the surface plot to assist with the identification of radar contact. So basically, the navigating officer and the blind safety officer will communicate between each other to maintain the safety of the ship in low visibility. So next is, in low visibility, the NO conducts the blind pilotage from the bridge radar display, monitored by the BSO. If reports from the NO and BSO disagree, immediate action to stop the ship may be necessary until the position has been accurately determined. So once the NO and the BSO disagrees about on what action will be taken, it is necessary to stop the engine of the ship, in order to assess the situation properly. So next is the place and the duties of the BSO, NO, and the other officers on this watch. So place, operation room. It is where the blind safety officers do his duty. His duty are to monitor the ship's position as a check on the ship's navigational safety, and then, using the most suitable display, coordinates navigational and anti-collision information to the bridge, although he does not supervise the surface plot, but he must keep an eye on the ship's situation. So next is still on the operation room, the assistant of the blind safety officer, and he plots radar fixes and other radio aids. As appropriate, generates DR and EP, assist in identification of marks or ships, checks ES, reports with charted depths. Still in the operation room, the anti-collision plot. A suitable experienced officer or the most experienced senior rate is in charge. Passes anti-collision information to the bridge to coordinated by the BSO. Next is the sonar control room. It is the sonar controller. He reports sonar information as ordered by the BSO. So that's all. Thank you.
This is Decadet Mancao Glenloyd, and I am going to continue Decadet Laban's report. Okay, so general principles. Number 1. The navigating officer should navigate or pilot the ship. So we know that the navigating officer is the one that is highly trained in order to attain safe and fast navigation. That's why he is the one that is assigned. Number 2. The captain should have easy access to the blind pilotage position and the navigating officer. So usually the blind pilotage position is commonly located on the bridge, and the navigating officer is always on the bridge, always on that position, so that he can monitor the progress of the vessel's voyage, and also it is on the bridge wherein the captain have the easiest access to in case of any emergencies or whatsoever. Number 3. The ship should be conned from the compass platform because it is only on the bridge that the feel of the ship can be retained. So as what I've said, that it is on the bridge that the feel of the ship can be retained. Number 4. The captain, the blind safety officer, the officer of the watch, and the officer in charge of the anti-collision plot should all be carefully briefed before the passage by the navigating officer so that they are all entirely familiar with the visual blind plan. Alright, so before the passage, the navigating officer will make a plan, a visual blind plan that comprises the prior preparations before entering restricted waters. So in that plan, it is important that the captain, the blind safety officer, the officer of the watch, and the other officers, that they should be carefully briefed in order for them to be aware and so that they can also help to whatever arising problems that may exist. Number 5. Navigational charts with the navigational officer's prepared visual or blind plan must be available on the bridge and in the operations room. So we know how important navigational charts are, and it is one of the things that the navigational officers had planned before entering restricted waters. So it is important that these charts to be available on the bridge or in the operations room so that the other crew members that are involved could check it once they are needing it. Number 6. The whole pilotage team should be exercised as frequently as possible in clear weather and visual and blind techniques. Only in this way can the necessary confidence in the system be built up, which will allow runs of some complexity to be conducted safely in blind conditions. So this is like an emergency drill, just like having a drill for during fire or any other things. So this is important because having an emergency drill will make you to be prepared once the real thing will come through. For example, you are already entering a restricted waters. So once you have practiced what are the things that you should do on clear weather conditions, it will be easier for you and your team to perform those tasks during those blind conditions. Number 7. The blind safety officer should be closed up on all occasions of entering and leaving harbor and passages through narrow waters when special sea duty men are closed up. The blind pilotage team should be regarded as part of special sea duty men. Number 8. There should be good communication between the blind pilotage position and the blind safety officer and personnel manning navigational aids fitted elsewhere. So we know that good communication is always the answer of attaining good results, and the blind pilotage position and the blind safety officers are the vital factors on attaining a safe voyage during blind conditions. That's why having good communication between these two is the key. Number 9. All members of the team should be encouraged to admit any doubts they may have regarding the information acquired from the sensors. So this is this applies to any conditions to where you are in case you have any doubts or any questions regarding the instructions or the procedures to be done. You should always ask it to the ones that are having knowledge towards it, so that you would know and your mind would be enlightened. Okay, so there comes the blind pilotage planning. So as its name suggests, this is a planning made before entering unrestricted waters. This is a this is doing preparations and preparing necessary things on what to do when you are already on restricted waters. So number one, normal planning considerations for selection of tracks apply. Blind and visual tracks should be the same to enable the transition from visual to blind or vice versa to be made at any time, and also to allow one plan to be used to cross-check the other. Number two, the number of course alterations should be kept to a minimum to reduce the workload in redrawing parallel and wheelover lines. So we know that parallel indexing is important in order to keep the ship on a safe manner. And when the ship alter course, redrawing parallel run is complex. That's why we should minimum the course alterations in order to reduce the workload of the crew. Number three, always try to have two parallel index lines where possible, one on each side of the track, and this will provide a check on measurement, mark identification, and can reveal index on linearity errors. Number 4. Objects to be used both for parallel index lines and for fixing must be carefully selected. They should be radar conspicuous and unchanged by varying heights of the tide. Clearly mark on the chart the objects to be used for fixing and brief the assistant. Avoid if possible by fixing radar range and bearing on a single mark. Number 5. The range scales to be used require careful consideration. Accuracy is greater at short ranges, but marks may pass more quickly than at a distance, requiring more lines to be drawn. So when operating on short range scales, it is essential that the BPO or the blind pilotage officer frequently switches to longer ranges to keep aware of developing situations. So changes of range scales and parallel index marks should be pre-planned and marked in the notebook. So the stage at which charts will be changed must also be carefully considered. So short range scales are important because it is more detailed, but it is also important to use the long ranges so that the navigating officer should know what are the developing circumstances. Like, he will know that there are more ships on the vicinity, on the 5 miles ahead. If you are going to use 3-mile scale, then you will know what are beyond of that scale. So it is also important to use long range scale, and the change of range scale and parallel index marks should be pre-planned and marked in the notebook. So the notebook is like a logbook wherein you would write here the changes that you have made, and this is important because this is significant for future references when there are problems that will arise. The 6 is tidal streams and currents should be worked out and noted for calculations of courses to steer and for the calculation of estimated position. So this should be displayed on the chart and recorded in the notebook. So just like what I've said, the details like tidal streams and currents and the calculations of this and the courses to steer should be put in the notebook for future references. Number 7, expected soundings, allowing for height of tide and calibration of echo sounder should be noted for each leg. So the possibility of being early or late should also be borne in mind. So that will be all for my part. The next reporter would be Decadet Murto.
I am Decadet Murto, and I will be continuing Decadet Mangkao's report regarding the blind pilotage planning. So the blind pilotage planning consists of different steps, and I will be continuing the steps that Decadet Mancao previously discussed. So on number 8, all hazards along the track should be boxed in by clearing ranges and their cross-index ranges listed in the notebook. So as we all know, the navigating officer has a notebook during these types of situation or circumstances, because having a notebook would give them a clear understanding, and it serves also as like a logbook or a guide to them on what's happening and what are the things to be used. And in this case, so all hazards along the track should be boxed in, so dangers that might cause the ship, the hazard should be boxed in by clearing ranges, and their cross-index ranges should be listed in the notebook used by the navigating officer. Then on number 9, we have details of lights and fog signals should be taken from the Admiralty list of lights or chart and entered in the notebook. Uh, So same thing, the notebook will be used by the navigating officer, but the details of the lights and fog signals will be listed on the notebook from the publication, which is Admiralty List of Lights. So in this planning stage of a blind pilotage, there are a lot of publications which will be used. Then we have here the chart should be drawn up using standard symbols. So of course, when drawing important and key symbols on the chart, we should use standard so that the officers, the captain can understand what you're drawing on the chart. So for example, this one, in a blind pilotage chart work, there are three key or vital symbols that you must understand. So the parallel index lines to stay on track. So this will be a straight line. We have clearing ranges, which will be broken lines. Then we have the wheel over ranges, and these are small, bold, broken line. So parallel index lines are used because this will serve as a safety parameter if your vessel is on track, especially with a restricted visibility. It is important that your vessel will stay on track that is laid out on the chart. Then we have your clearing ranges and the wheel over ranges. So wheel over ranges, this has something to do with the turning of the rudder at a certain point so that it will safely move towards a curvature. So this is where you change your wheel over, is where you change your course. The term dead range, you can see here, there are 4 figures here, is used to describe the range of a mark ahead when anchoring in a chosen position. The term may also be used when measuring the progress of a radar conspicuous object along a parallel line. So you can see here a parallel index line or a range line here. So it is a 1 nautical mile cross index range. So this is the range. Then here we have clearing lines. You can see here the clearing ranges, the broken lines. Then this is the distance from the nearest shore, 1.6 nautical miles. We have your wheel over ranges. So this is most likely where they alter their course, change of course, where they change the rudder. Then here we have the dead ranges. So you could see here, it is used to describe the range of a mark ahead when anchoring in a chosen position. So say for instance, this is your chosen position. So it indicates ahead the distance from the nearest shore. So if this is your position, this is your anchoring position that you have chosen, it is a 2.5 nautical miles from the nearest shore. And it is also used in measuring the progress of an object along a parallel line. So if there's an object here, it is used to measure from the nearest shore or from this parallel line. So for example, there's an obstruction here, then you could measure it from here, the distance. So next. 11. The notebook should contain the full plan, neatly and legibly, recorded in chronological order. Sketches of both chart and radar display can be of great assistance to the blind pilotage officer in evaluating a picture. A suitable notebook layout supplementing as a guide to blind pilotage planning. So, The notebook is indeed integral in this operation. So sketches of both chart and reader display made by the navigating officer can assist and give a better understanding to the blind pilotage officer when he will be evaluating a picture. So proper procedure and layout should be done in the notebook, which we'll go to that later. So tracks plotted for entering and leaving the harbor should not appear on the same chart simultaneously, because this will lead into confusion to the navigating officer and the BPO, because when you have a lot of tracks, it will be hard for the BPO and the navigating officer to comprehend which is the right track. So to avoid confusion and to eradicate misunderstanding, it is better to use two charts for entering and for leaving the harbor. Then next we have the clearing range should be simple, safe, and easily interpreted. So in the clearing range, broken lines, it should be made simply and it should be evident, and it shouldn't be mixed with the other symbols on the chart. Objects used for wheelover should be conspicuous, easily identifiable, and suitably located adjacent to the track. So the wheelover should be seen, should be evident, and it should be identified easily by the navigating officer or the BPO, and it must be adjacent to the track or to the parallel lines. So here we have an example of a pilotage preparations of the chart and displays. So here in the first, you can see here, so they use two charts here, one for the entering and one for the leaving the harbor. You can see here the wheel over point. You can see it's very evident, it's very identifiable. The small broken lines. Then we can see here the clearing ranges. It is longer broken lines. And here, these are what we call the parallel index lines. This one, the straight lines. So that is what you'd see on the chart with regards to blind pilotage. So blind pilotage execution. So you need to carry out a time check to synchronize the clocks and watches. And secondly, we have to before that, so we're done with blind pilotage planning. We'll now go on to the execution. So the execution is where you'd apply all the things you've planned on the chart. So you'd apply it. So on the radar display, keep one set of parallel index lines drawn up ahead of those in use. Any more will clutter the display excessively. Rub out lines as soon as they are finished with. Identify contacts early by range and bearing from charted object. So an accurate estimated position is most useful as an aid in identification. So you must know the contacts early by range and bearing so that you know your fix, and an accurate estimated position of your vessel is most useful as an aid in navigation in a blind pilotage, because of restricted visibility, it is integral that you know your position and your estimated position. So you must be quick and you must be accurate with regards to knowing the objects that you're using as references. Then we have here fix at frequent intervals and immediately after a change of course, the dead reckoning or estimated position ahead. So yes, during restricted visibility, it is important that you will know your dead reckoning or your estimated position as an advance, because you must be one step ahead in these kinds of situation, because in restricted visibility, it's so hard to see in your surrounding. So you must advance, you must make the right and appropriate actions. So a suitable fixing procedure is, an example, the BPO assistant would say standby fix in 1 minute. So this means that he would be getting the fix every 1 minute. Then the BPO, Roger, using points A, B, C. So these are references or points that the BPO assistant, the BPO is using as to gain a fix. So we have three reference points to know your fix. Then the BPO assistant writes these in the notebook. So this is how a notebook would look like, the navigator officer's notebook would look like. So it can be filled with with courses, remarks, distance to wheel over point in miles, minimum depths, or the navigating officer or the BPO could indicate here the, like what I've shown earlier, the list of lights and fog signals. So here, first example, 70 degrees is the course. So approach 12 speed knots on pier route beacon. So port headland 7.2, starboard headland 2.8, head buoy port 5.2. So these are remarks made by the navigational officer. Then this is the distance to wheel over point. So it's somewhat like a logbook, but used in blind pilotage in our report. So the notebook is used for blind pilotage, but it could be used in many parts as to what the navigating officer would use it for. The minimum depth 14 meters. You can see this in the chart. Then the course is wheel over to 0 degrees 15 degree port helm. Then here we have example 20 degrees on head mark. So these are remarks again made by the navigating officer. So that would conclude my reporting, and the next reporter will be Decadet of Yanga, and he will be continuing the blind pilotage execution. So thank you for listening. I am Decadet Merto, and I will be giving the floor to Decadet of Yanga.
So in continuation with the execution, the BPO or the BPO assistant fixed now. The BPO marks the point on face of the display. Then the BPO assistant notes the time. The BPO then ranges off the marks drawn on display and passes these to BPO assistant. The BPO assistant then records the ranges, plots the fix, and generates fresh DR and AP. So next will be the ship's speed. So one of the factors affecting the choice of ship's speed will be the rate at which the BPO and his assistant are capable of dealing with the radar information. Next thing is the commentary and conning advice. Maintain a steady and unhurried and precise flow of information to the command. Distance of track, on track, or the course to maintain or regain. The distance and time to next wheel over new course. Present or the new course clear of shipping. The adjacent marks or hazards. Expected lights and sound signals. The expected depth and echo sounding. The minimum depths. So when fixing and result of fix, the EP to next alteration. So next will be the maneuvering lights. Examples, the 5 cables clear to starboard, 1 cable to port. So if in any doubt, say so, and if necessary, stop the ship. So next will be, it must be appreciated that whatever the technique employed, a drift of line is likely to be detected less readily by radar than by visual methods. Next, it is vital to pay attention to the echo sounder and the least depth expected. The nearest land is usually the bottom. So moving on with the blind anchorage. So a blind anchorage should be planned in the same way as a visual anchorage, but remember to allow stem to radar instead of stem to standard when plotting the let go position. As shown in figure 25, parallel index lines should be used to guide the ship to the anchorage position, and she must stay boxed in by clearing ranges. Distances to run can be obtained by using a dead range on a suitable object ahead, or by measuring the progress of a radar conspicuous object along a parallel index line. Full details must be shown on the chart and in the notebook. Distances to run must be marked on the face of the display. So, as with the navigational records, when carrying out a blind pilotage passage, the navigating officer or the BPO will be too busy to maintain a continuous written report or record. It is essential that such a record should be kept, and in comparatively unrestricted waters, it is normally sufficient for this record to be kept on the chart itself by plotting fixes and noting the positions and times of alterations of course and speed and other relevant data, in addition to the record in the navigational record book. In more restricted conditions, however, the navigating officer or the BPO's running commentary to the captain should be recorded on tape if possible. For example, number 7 buoy fine on port bow, 8 cable ships 50 yards to port of trucks, steer 136 to regain. So in conjunction with the navigating officer or the BPO's prepared notebook with chart, the recorded fixes and courses and speeds, this record should suffice for any subsequent analysis required.
Good day everyone, this is the Cadet Paganas. The next will be the horizontal displays. So horizontal displays is available in the operations room. The whole passage may be prepared in advance on a series of overlays. The BSO's assistant changing this at appropriate times. And the horizontal displays has its own disadvantage, which is the drawback of this method is that all tracking and other additional marks made by the BSO are lost at each change. And for the conclusion, the IMO gives recommendations on pilotage, which are as follows. So for merchant ships, regulations for pilotage are laid down by the national authority or the shipping company and in the orders for the port concerned. And in most ports, a pilot is usually required to take full control with regards to the handling of the ship from the pilot boarding place up to the berth. Although there is a pilot on board, it does not relieve the master or the OOW from his obligations to keep the ship safe. The master during this time shall make sure that the expertise of the pilot is supported by the navigational bridge team to get the ship to berth safely and efficiently. And lastly, the OOW must coordinate with the pilot closely and to accurately check the ship's position and movement. And in the event that there is doubt regarding the pilot's actions, it is up to the master and to the OOW to take the appropriate action to keep the ship safe. And that's all for our report about planning and execution of blind pilotage and anchorage. Thank you for listening.